Hi, my name is Joseph Nunn, and welcome to SocSci10 Spring 2021. I'm one of the TAs for the class, and you can reach me at my email at joseph.nunn@uci.edu. So if you need office hours, we're not going to have office hours because people are all over the world and can't really expect everyone to make the same time. So I'll be meeting with students based on appointment. Just send me an email, we'll set something up, and we can meet then. And I'll be making these short presentations every week. And this presentation and the following ones are all going to be focused on things you might need to know, understand for the homework that come from the reading. So the first thing we're going to talk about today are dependent versus independent variables. So a dependent variable, this is the kind of variable when you're looking at your experiment that's out of your control. You don't really have control over it. It depends on other things, and it's what you're measuring. Okay. Now the independent variable, that's how you control your experiment, right? You can twiddle this variable, set it to different settings, and then what you do is you look at the dependent variable to see how it gets changed by what you've done to the independent variable. And a good example of this would be tax rates and economic performance. Which you might measure as GDP or gross domestic product. So tax rates, in this case, they're independent variables. It's something that politicians can change, right? They can set the tax rate. And then what you do is you can by looking at the dependent variable, in this case, the GDP, you can measure that to see the effect changing the tax rate would have on the gross domestic product. So this is a good example of how independent and dependent variables can interact in an experiment. Another way to talk about variables is qualitative versus quantitative variables. So a qualitative variable is a variable that can take on a value that's basically a category. True or false. These are categories. There's no way to really be partially true, right? Variable can't be partially true. It's got to be either true or false. These are the categories that you're using. So, a Boolean variable in that case, that would be considered a qualitative variable. Now, a quantitative variable is a smooth gradient between on a scale. So, an example of a quantitative variable would be if you're driving a car, you've got a gas tank, you've got a fuel gauge. That fuel gauge can go to any point in between the maximum and minimum values. It doesn't click between sections, because it's measuring the amount of fuel, and the amount of fuel varies smoothly in between the endpoints that the variable can take on. So this range, this smooth valued range, that's what a quantitative variable, that's the kind of values a quantitative variable can take on. A good example of this would be grades. So letter grades, the letter grade you get, that's a qualitative variable. You got an A or you got a B. If you're just using the typical grades without pluses or minuses, you've got A, B, C, D, E. And these grades are simply these different categories that your grade can fall into, right? Now a numerical score, that is a quantitative measure. It's a quantitative variable, and that can be have a smooth gradation. So you can have a 93 or 94. You can even have a 93 and a half. You can get in between all of the values to find values that are in between there. There's a smooth gradation, and that is a quantitative measure. And finally, we're going to talk about the levels of measurement. So when you're looking at these dependent variables, how are you going to measure them? There are a couple different scales you can measure them on. One is nominal. So a nominal scale is just number of categories. You're really just looking at this category. What category is the dependent variable in? It's like a mathematical set. Is it in the set or is it not in the set? And these sets, there's no real ordering between them, right? You can't say that one is more than another, or you can't line the sets up in a row. If you have a red set, a blue set, and a green set, you can't say that red is in between blue and green. Although, of course, you could think of it as far as like wavelength of lights. But in this case, we're just using red, green, and blue as labels, right? Just labels, set labels. So there's no real in-between sets there. However, could have a different type of scale. You could have an ordinal scale. Now, in an ordinal scale, what you're going to get in an ordinal scale is you're going to get sets that have some kind of organization. What if you have a low set, a medium set, and a high set, right? You could have values in between these. So you could say that, okay, if we have a variable and it's in the medium set or in the middle set, you could say that's in between the two sets. It's closer to the low set than the high set is. So there's some kind of order to these categories, right? And it's kind of like integers on a number line. You know, there's a certain number of integers for a section of a number line. You can't really get in between, but there is definitely an order to these, and that is an ordinal scale. Another type of scale is an interval. So an interval is kind of like a smooth gradation. This would be more like having a real number line, right? So you can get in between any two values to a new position without having like a set number of categories. You just have a range, like a real number line. That's another type of scale. And finally, the ratio scale. This kind of scale is actually a scale invariant. So if you use your fractions, you know that 1 over 10, that's a fraction. That's a ratio. It's 1 to 10. You could have another ratio, could be 10 to 100. So there we've changed the scale. We've got a lot more items we're looking at, right? We've got a lot more items we're looking at. 10 items to 100 items. But what's that ratio? That ratio is still 110, right? So you can see that ratios are scale invariant to the number of items you have. It doesn't really matter the number of items you have. You know, so it gives you a way to compare ratios of disparately sized sets. So that can be, you can think of that as rational numbers, you know, which are numbers that can be expressed as ratios, and that's kind of a combination of the ordinal and interval scales, and it's probably the most robust scale to use. Now, these are, I think, all the basic concepts that you need to understand for the first assignment, and I think we're going to end this today, and I'll see you guys next week.